Hi everyone, my name is Jess Larson and I am meshIQ's events manager. I would like to welcome everyone attending as we really appreciate you taking the time to join us. In case you don't know, we present monthly Tech Talk webinars on different middleware technology topics. At the end of this presentation, I will include links to watch past Tech Talks on demand if you missed any of the previous webinars. So today's topic is scaling your Kafka environment using Kafka partitions. Feel free to send any questions you have throughout the presentation in the Q&A box for the Q&A portion at the end of the webinar. Before we start, I would like to introduce our speaker today. Richard Nikula is meshIQ's VP of Development and Support. Richard is responsible for the entire development lifecycle of all meshIQ products. He is a graduate of Washington State University and currently lives in Texas. I will now pass it over to Richard to get started.
Thanks, Jessica. All right, so let's go ahead and cover today's topic, which is scaling your Kafka environments using Kafka partitions. So Kafka partitions are a key element in the operation and the scalability of Kafka, and that's why we're really going to cover them and try to get clear as to what they're for. So we're going to just cover a couple of key topics. The first is, what is a Kafka partition and how is it used? Just some basics. And then we're going to look a little bit into how messages get distributed across the partitions within the topics. And then we'll use a couple of examples to actually look at how that actual partition allocation is going, and then some ideas about tracking it over time. So that's what we're going to cover today. Okay. So what is a Kafka partition and how is it used? So really basic Kafka 101 is topics are made up of a log, right? And messages come into the log by the producers, right? So if something produces messages, they get put onto the log from start to end. It's a mutable list of messages. Basically, messages come and they just get logged, right? It's different than a queuing system, which you might be familiar with, where messages get put onto a queue and taken off of a queue. This is a list, and the list is basically maintained forever with some trimming that happens over time. But in general, that's just a list of messages being stored. And then you have a consumer or consumers, and the consumers read those messages, and that's how Kafka works. So it's a fundamental capability of Kafka is the concept of a topic log. So what is a partition? Well, a partition is the way that Kafka divides those logs across multiple nodes within the Kafka cluster. And this is a bit of history. And again, as with many things in IT, you have to look back and say, what was the factor that was going on? And when Kafka was being before it was developed, the use case that they needed was a very high volume messaging system. And most of the messaging systems that existed up until this point were like the other example I said, which were like a queuing type system. People, we tend to forget, if you go back, not too many years ago, right? Discs were still fairly expensive, right? And so people didn't have, they didn't want to use a lot of disk space. So and processors, there was only so much capacity, and networks, there were only so much capacity. And so a lot of the systems of the day lived in a world that was based off of restricted resources. Well, what if you could just go and get a whole bunch of really cheap computers and hook them all together and put them, to solving a task, right? We all know that's parallel computing, nothing new, right? Well, it hadn't been applied really in the messaging area before that. And so basically that's what they did with Kafka is they said, let's make a system that allows us to have this thing distributed out over a number of different nodes. But of course, then there were some dependencies on that, right? The network needs to be fairly reliable and fairly quick. And most of us today kind of take that for granted. We don't think about slow networks, right? We have fast networks even at home compared to what many businesses had internal not that long ago, right? And it also then allows you to divide that work up. It increases the ability to do concurrent processing, even within the same server. And all of that provides scalability, separation, and additional fault tolerance. So let's look at that in detail. So here's our log again, right? Same thing we had before, but now instead of having a single log, we now have a log divided up across partitions. And for this picture, it's just really showing the basics of how that works, right? So each producer is producing to its own log. And keep in mind, those could be on completely different servers in completely different, Kafka environments, brokers. Um, and then similarly, the consuming is the same way. Now, keep in mind, there's also producers and consumers who are talking to these services, but these are the services themselves acting on Kafka's behalf, right? So it can consume those messages for you off of the queues, right? So again, higher scalability. And, you know, when we talk scalability, some people think, okay, well, that's, hundreds of things or, thousands of things. Well, that's scalable, right? Well, keep in mind, right, that Kafka, and it's not a hard limit, but they recommend about 4,000 partitions in a broker, right? And then 200,000 partitions in a cluster, right? So again, this is highly distributed. Imagine that if that really were the case, that you had 200,000 partitions and you had distributed them each to their own commodity server running a piece of that. That's a pretty big network and a pretty big investment. Now, obviously, you probably don't have, it all dedicated to one partition, but in reality, you could, and that's the design of Kafka, highly scalable. Okay, now one thing about Kafka is that the messages have sequence numbers, are called offsets. And so within a given partition, the data that's written there is ordered by its offset. But beyond that, there is no order across these partitions, right? So just looking at this picture that I have here, you can't tell if oh, look, there's two message nines. Well, you have to have some typo in your stuff. If message 8, just ignore that double message 9. If message 8 here arrived before message 6 or after message 6, there's no way to tell from this picture as to how, they are ordered. The only thing I can tell you is this message 6 came in after this message 5, right? And this message 7 came in after this message 6. But I can't tell you anything about, these could have been here for a year and these could have got here just 2 seconds ago. All I can tell from looking at the particular Kafka without going obviously in and looking at the messages themselves. But that's a key part of this, is that the Kafka partitions, the data is separate amongst them. Now there's an advantage of that, and we'll mention that in a bit. Okay, you also have fault tolerance. And so in Kafka terms, that's called replication. The replication is done at the partition level. So each partition has as many fault tolerant copies as you need, right? So this allows so that in case one of those commodity hardware, right? So again, we'll stick with that model for the time being, right? Well, one of those servers fails. Well, what happens in that case? Well, in Kafka, it's pretty simple, right? This guy goes away. Well, you've got a copy of that data on another server. You just switch over to using that Kafka or that copy. And you can have as many as you want. If the servers are really unreliable, right? Right. 3, in fact, you'll hear I have a primary and 2 copies, right? Well, you say, well, gosh, that's a lot of replication, but in reality, that's not much, right? Because basically, if I lose this server, I'm down to basically 2 that are left, right? And I only need one of those to fail, and I'm down to the last one, right? So, fault tolerance by replicating the partitions gives you a lot of capabilities to obviously to recover in case needed, right? So that's a key element of the partitions is they are replicated on each of the environments. Now, obviously, you don't want to replicate it on the same server that you're on. You want it on a different server. So again, you want to run a lot of servers so that you can have this thing spread out across a large environment. If you had 3 servers and you had a replication factor of 3, you really don't, because as soon as one of that servers fails, you're already down to only 2 servers. So you want to have 10 servers with a replication of 3, or 50 servers with a replication of 5, so that you have a lot of backup capability. Okay, so let's talk about reading the message. We talked about writing the messages. So let's talk about consumers. And there's a simple thing in Kafka. You can have a consumer, and consumers can simply subscribe to a topic. And then when a new message to that topic appears, they get a copy, right? So right here, so we'll just do a simple, we got another one there, we got one there, and I subscribe to those and I got those messages, right? So once I start, I can see everything that happens after I start. That's a very simple subscriber model within Kafka, is just consuming messages. And there are use cases for that. I just simply want to know, I'm interested in, the topic is stock trades, and I only care about stock trades that happen after I start listening. I don't care about the ones from yesterday. I just want today's, right? So that would be an example of a consumer listening to a topic. Now, you can also start at the beginning, right? So a consumer could say, I want to read this topic from the beginning. Well, what does the beginning mean? Well, in Kafka terms, it's, as I mentioned earlier, there's really no order. So the beginning really just means, well, I'm going to start reading from somewhere, which is the first partition and the first message. And I'm just going to read those, and then I'll read those and read the next, right? So if you wanted to read the whole topic, you could, right? But those are your 2 choices in Kafka in general in how you consume messages as a consumer. There's another concept in Kafka, which is a consumer group. And a consumer group is a peer set of consumers who want to do the same thing. We're still in the mode of we want to consume the messages. So we want to get the new messages as they arrive, right? So we can have multiple consumers. So let me start off with, I'll do 2 consumers, 1 and 2. And I'll go ahead and replay my same message as I did before. And consumer 1 gets message 15. Oh, and it also gets message 10. And then, now we actually can see there's, here's 17 came in, and then 11, right? So consumer 1 got 3 of them, and consumer 2 got 2. Okay. Well, you might wonder, well, why didn't it split them, right? Why didn't they both get half, right? Well, it's because a consumer is associated with a partition. You're going to consume messages from a partition. So in this case, obviously, consumer 1 is associated with this partition, the blue, and the green. Those are the partitions it's doing. And we can see that consumer 2 is with the gray down here. Can't tell for sure which one of it would get the next blue message, but probably 2, but we don't know, because again, it's the logic is based off Kafka's internal processing as to how those consumers get hooked up. Now, you might say, well, why didn't it just do them evenly? Well, there's one really important reason, which was back to remembering, as I said, that the order of the messages within a topic or within a partition are in order, right? Well, if you need to process the messages in order, and you have multiple messages coming in, you need all of those messages to arrive in the same consumer, right? So if this guy got 10 and this guy got 11, well, if those were supposed to be processed in order, they weren't, right? Because so that's why. Okay. So let's increase it. Let's go to 4 consumers then, right? Because it sounds like a better idea, right? Why? Because now I have 4 partitions, right? I have 4 consumers. So now if I read message 15, that goes to consumer 1, 10 comes in, goes to 2, 4 comes in, goes to or 17 comes in, goes to 4, and 11 comes in and goes to 2, right? So we got a much nicer distribution here. Everybody's happy now because every consumer processed 1 partition, right? So that's pretty cool, right? So gosh, if 4 was good, then we should do 6, right? Because it seems like a really good idea. So let's do 6 partitions, right? So what's going to happen? Well, exactly the same thing is going to happen because Kafka can only associate 1 consumer with 1 partition for the same reason I mentioned a minute ago, right? Which is, you can't, you need to process these messages 10 and 11 in order. The only way they can get processed in order, is to have the same consumer process them together, right? So again, 5 and 6 in this case don't do anything. They're just sitting there idle. In fact, they have no messages. They would only get involved if, like, consumer, 3 here happened to die, and they need to, we need to reallocate the partitions. Well, the fact I have a spare one probably means it'll get the partition 3 here as its next go round, right? So that's the only advantage, is if in the case of, say, a failover. Okay, so that's how the consumers kind of work. Okay. All right, so let's go back and talk about, well, now we've seen the partitions, we've seen how messages show up. Well, how do the messages themselves distribute across the partition? So there's really 3 main options as to how you can assign a partition for a message. The first one is the application can actually say, I want to write this message to partition number 1. I want to write this one to partition number 5, right? Right? That's up to the application. And you might say, well, that sounds interesting, but why? Why would you do that, right? Or why would you do that? Well, the answer is you probably wouldn't in most cases, right? Because if the application is in charge of writing the partition, then it somehow thinks it knows better than Kafka where those messages could go. Well, what if you want to add another partition, right? So we had originally started with 10 and now we want to go to 20, right? Well, I got to rewrite my application to take into account which partition I'm going to write to. That doesn't sound very good. So it's not used very often, but there are use cases why you might want to use it. Consider a case where you have something like an embedded Kafka server, maybe in your car, right? Right. Sounds crazy, right? Right. Your car has an embedded Kafka server, probably has more than one, right? Well, and you want to send messages, from the brake pedal to the brakes, right, through Kafka. Okay, maybe probably don't want to do that, but in case, let's say you do, right? Well, you know what partition you want to send it to because that's how you've designed the car around that model. You could go ahead and say, we'll send this one to partition 0 because the brakes listen on partition 0 and everybody's in agreement on that, not likely to change. So an embedded type Kafka would be a good example where you probably, might want to do something like that. Okay. Random, right, is the next choice, right? I call this opportunistic round robin, and I'll explain that in a minute, because if you look at most of the background material for Kafka, it will say that the Kafka partitions are round robin. And I sort of generalize that a bit to say it's opportunistic. And the reason is that it actually does take into account that that it's trying to separate resources out, but in sometimes round robin is not the most efficient way to do things. Um, so, and again, that's one option. And then the final one is the most commonly used, which is you have a key that gets hashed. Okay. And the key, it's not like a database key. So a lot of people, if you think of like a key for a database, the keys are typically unique and you use it to go find a specific record in a database, right? Well, that's not what this is. This is a key that is hashed that's used to come up with the partition that that particular message can go to. It's non-unique. And in fact, any message that has the same key will go to the same partition. So let's say you were doing, an EDI workload and you wanted all of the messages for the same PO to go to the same partition. Well, you would make the PO number the key, and then all of those messages for that PO would then go to the same partition and would get processed downstream by the same consumer, right? So if the consumer wanted, you wanted to read you know, the PO and the acknowledgement and the the different messages that came in, you could read them all and you would find them all on the same partition. So that's again an example of that. Okay, already mentioned this. Order of delivery is dependent really just on how the messages arrive, right? So in this case, you can see here, I've got key 1, I had 1 message, I had key 3, I had 3 of those. So they went to the same partition. Oh, here's key 2, there's 3, here's 4, here's 5, right? 6, 7, 8, 9, right? So that's nice, fairly nice distribution there of keys across the partition. And again, the key thing that I was, no pun intended, the key thing that I was referencing is that all of the key 3s, all of the key 9s, all ended up in the same partition. Okay. All right, so let's look at some of that. I'm gonna use the meshIQ platform to do that. That's not what today's session is on. If you're interested in the meshIQ platform and what we can do for your Kafka environment and that would be, we have some additional sessions on that. But today I'm going to use that, but I'm going to show you some examples of what I observed. Okay, now again, this is a simple environment, but I just want to show some examples to kind of back up what we just learned, right? So in this first example, I did 6 no key puts, okay, to a topic, right? And it was a simple message. In fact, it was just a hello world kind of message, wasn't very big. And I put those 6 to a topic. And then what I'm showing here is the actual breakdown of the partitions. Okay. Now it's actually somewhat hard to get to this level if you're just running native Kafka toolings. It will tell you the partition counts and the types and some of that. But this is an example where we drill in a little bit further and give you details down at the partition level. So this is going down from the topic into the partitions that back up that. And this is a really simple topic. It has 3 partitions. Okay, so it's not, again, for these use cases, I didn't go into the 4,000 partition examples, which we'll do the same thing just on a slightly different scale. And then if you look over here to the right on this particular screen, you'll see that it lists the total number of messages and then the available, because I didn't have any consumers running. I was just, for the purposes of this, I just wanted to show where the messages ended up. And you can see here that it ended up with 1 in partition 0, 1 in partition 2, and 4 in the partition number 1. And again, that was the example of it wasn't very round robin, um, because obviously round robin, they should have all had 2 in them, right? If it was really true round robin. And I could have done this same example with 10,000 messages and you'd have seen the same sort of thing. Although that's sort of the key, and is that the server that's processing is basically doing it based on its own resource allocation. So the busier it is, the more likely it's going to push that work off to another broker to do the work, right? So, and again, in a typical Kafka environment where you have lots of things going on versus something here, which was a demonstrating system, that round robin will look more normal, right? It will behave more like a normal round robin because it's always busy. So it's always going to pass it off periodically to one of the other servers to do it. But it does like to do it itself. Okay. And then I did the same thing. I put another 18 puts, message writes to that topic. And this time it was a multi-line message. So there was 3 messages in each topic. And so again, you can see that, again, it splitted it out. Now this looks pretty round robin. And when I first looked at this, I went, oh, wow, look at that. It evenly distributed them. But it's actually pretty interesting because if I actually go in and look at those messages, it didn't actually round robin them. What it did is it put all 3 of the messages on the same topic. So even though, these messages, remember I originally said that you're not guaranteed to have non-keyed messages appear in the same partition. In my particular case, all 3 of the messages that were put together ended up going into the same partition. But that's a random behavior. Okay, again, that's why I called it random with the opportunistic. Isn't a fixed behavior. I cannot rely on that. I could run this same test again with a little bit of more workload on, and this message would go to 1, this one would go to 2, and this one would go to 3. Right. So that's, both sides of that, right? It's not round robin, so don't rely on it being round robin, but it may be round robin, so don't rely on it being not round robin. Okay, so let's look at a different example. Let's look at using a topic key. So what I did, I just put, this is just what I went in and I used the console command, and I just put in, I think it's 13, magic number 13 messages where it's a key pair, right? So this is the key, and then this is the data that I wanted to store, right? So that's what we're looking at here. And you can see I've got this one's there. I've got a multi-data example. I've got a random key, some stuff I threw in, a number, another number, and then some customer sort of thing, where it's got some, secret encoded message here that's, some customer related thing. And I've got those, right? So that's my data just for the purposes of sharing it, right? And then I sent that to a topic that now had a dozen partitions. So let's, 3 was fun, but 12's got to be better. And I sent those messages. Okay. Now, in the end result, I actually only ended up with data in 7 of them, right? Because it was a hashed key. Okay? It didn't distribute them evenly. It distributed them based on the hashing key. And in my case, that was how they broke apart. So I ended up with 4 messages in a couple of them. And if you've paid attention on the last slide, you'll know why. And then 1 message in some of the rest. Just the nature. Again, I didn't send a lot of messages here because if I sent 1,000 messages or 10,000 messages, I would just be explaining the same thing over and over again. So we'll just make it simple here with our dozen messages. And that's how it ended up. And in fact, if I go in and just, there's a little mock-up just to show you from the data that we got back, showed up on one screen here as I browsed over them, that I got, this guy got this random one, this one got here, this multi-key went to this one, and actually random key ended up being hashed to the same one, so he ended up here. And then as expected, the 4 that had my secret code in them or my customer ID or whatever ended up in the same partition. So again, how the data got allocated, very easy to see. It matched our expectations, bottom line. Okay, a couple of other quick examples is it was great looking at the partitions statically, right? But what about over time, right? Just like I was saying, there was no time sequence sort of in that data I just showed you, any of the examples up to this point, right? Some of those messages could have arrived earlier, later. Is it all, is it seasonal? How does your message topic usage behave? So to do that, you would want to track the data. And that's where our track component comes in within the meshIQ platform. But here are some examples of that. And I just took it, and it's hard to, get a good screenshot that shows up here and would, show how this is being used. But But just a couple of examples where here we've got a nice little chart of partition usage over time. So again, this is looking at the, the scale is the number of messages put into that partition over time. So we can see that trending, right? So that would be over a month, this would be very much more interesting than just a dozen bars here that I can get big enough to show on the screen. Here's a separate sort of view of it where, we're doing a line chart versus a bar chart, again, showing where that activity is, what the different partitions are doing and when. And then this bottom one was just kind of an interesting one because we had this big spike right out here toward the end of a whole bunch of messages ended up, everything had been pretty well evenly distributed, right? So again, the expectation is these lines should be pretty flat like this. Everybody should, if you're getting a good even distribution across your topics, across your partitions, then these lines should be relatively consistently uh, aligned. And then suddenly, wow, we got a big spike here in this partition of a whole bunch of messages showing up. Now, that might be fine. That just might be something you expect, but it's good to know. Again, if you don't track that, you don't know it. Okay. Okay. So finally, some final thoughts. Okay. One couple final thoughts, and then we'll go to any questions you might have. And that is that you kind of need to be able to track these partitions, right? And what their allocation is, and especially looking at it over time, right? They're a powerful core piece of Kafka, and that's why we have this session on it, right? But they're not without challenges, right? Imagine, right? I mean, and I'll go back to my original scenario of, okay, I have 2,000 partitions spread across 2,000 commodity servers, and all of my messages go to 3 of them. Probably not the best plan, right? If you have 2,000 servers and the workload is idea was to spread it across, you don't want it going to just 3 of them. So you want that even distribution. So, that may mean relooking at your key selection, uh, you know, figuring out if there's other better ways that you can do it. Uh, Now that may not be alone in itself. The data also may not be consistent, right? If in the real world, again, that's the difference between the real world and the real world, right? In the real world, we expect that things are relatively flat, right? Um, you know, it- and actually, I'll share a story with you. Actually, this goes back to many, almost decades ago. We had a system that was tracking time cards for people, right? And you would think, okay, well, time cards, everybody works pretty much consistently. Everybody's going to have, a time card for today. And so if you had a month's worth of time cards, you'd have maybe 20 per people, right? Well, turns out that I worked for a government agency that deals with transportation. And you might not know this, but when you go across, driving down a road, and in the US, and I'm sure it's true in other countries as well, but in the US in particular, especially the interstates, if you're driving down the road and you go across the bridge, there'll be a little ID over by that bridge. It has a number, right? And you cross that bridge and then you go to the other side and you go a little bit further and there's an overpass and you go across it. It has a number, right? Well, it turns out that the government requires time cards to be tracked against the bridge because the bridge has its own budget, right? The bridges were built using a certain fund, and the maintenance of that fund comes out of a certain budget. So it turned out that people who worked on like road repair and road cleaning crews could have 1,000 time cards in one day because they cleaned a stretch of road, right? Well, if your design didn't take that into account, which I know about this because our design didn't, that can cause a lot of problems, right? And so you need to at least understand your data and how it maps to the partitions. That's why being able to, get in and look at the partitions and see their content can help you. Okay. And then there's bad design. Of course, you can't do anything about it, right? I mean, you know, like I said, that wasn't a bad design they had for that application, but it wasn't optimal. Okay. And then there's one other thing, which is something called an under-replicated partition that you have to be on the lookout for. And an under-replicated partition is basically where one of those replicas is offline. Remember, I said that's a key part of the replication strategy is to have, you have 3 copies. Well, if you only have one at the moment, you're in trouble, right? Or if you're supposed to have 2 copies and you only have one, you're still okay, but that means you can't lose that one. You lose the backup you've got and you're in trouble, right? So you want to be on the lookout for that as well. So you again monitoring the environment and the partition is key. Okay. And in fact, one last screenshot from the meshIQ platform. Uh, Actually using the Grafana. You can use Grafana if you are a Grafana user. You can use our own Observe platform as well. But I just wanted to show that here's that view of the replica status um, in a Grafana screen. And of course, we have that key problem that I just mentioned. We have under replicated partitions right now. Again, in our simple environment here, it looks like we've lost a Kafka server, right? Because, we've got one and then, some of them have 2, but most of them only have 1 replica. So that implies there's at least 1 down. So again, that would be something you would want to alert on and be able to follow up. Okay, and with that, I think we are open for questions.
Thank you, Richard. Yeah, I think we have received a couple questions. The first one is, do you have any benchmarks or other data I can use to compare the performance of my application using Kafka?
Wow, good question. So yes, we do. I don't have a link. We can follow up with that, but we actually publish some benchmarks comparing Kafka and other servers like MQ and SQS. And in fact, we are just now within the next week. I think this year's benchmark will be published, so we'll make that. We can make that available. And it's also off our website. If you go to meshiq.com, search benchmark, you'll find it as well.
Great. Next question. Does the meshIQ platform you were showing require any changes to the Kafka applications?
No. So yeah, so that's a good point. The all the stuff that I was doing, we were able to collect through the Kafka APIs and through using Kafka topic information, no changes to the application. In fact, that's really one of the nice things about Kafka compared to a lot of the other earlier messaging systems is, you can use that data in multiple ways without having it actually impact your application.
Great. Well, thank you. I think if no one has any more questions, I think we can wrap up here. So thanks, Richard, for your presentation, and thank you everyone who joined in. We will have this Tech Talk available on demand, posted on our meshIQ website following this call at www.meshiq.com. We'd love to have you join us again at our next webinar on December 12th. It is on unraveling the security challenges of Apache Kafka, presented by our CTO. Well, thank you again, everyone, for joining, and have a great rest of your day.